All right, so I think this is recording. In this video, we'd like to solve these two inequalities and also to express the final answer using interval notation. So let's take a look at number 3. Step by step, we want to isolate the variable x. On the left-hand side, I'm going to apply the distributive property and have the opposite of x minus 8 is greater than or equal to. I'm also going to apply the distributive property here on the right-hand side and get 4x plus 12. So I like to get the variables on the left-hand side. I'm going to subtract 4x from each side. That's going to give me a negative 5x, and that's greater than or equal to. I'm going to add 8 to both sides and get 20. Now, when I divide both sides by negative 5, since I'm dividing by a negative number, I have to change the direction of the inequality, and positive 20 divided by negative 5 is a negative 4. If I make a quick sketch on a number line, I've got negative 4. To the left of negative 4 is negative 5, and to the right is negative 3. So negative 4 is often referred to as the endpoint or the boundary. Since it's less than or equal to, since this is underlined, I'm going to make this a solid dot. And this is why I like to put my variables on the left, because the direction of the arrow tells me what to shade, which direction to shade. X being less than or equal to negative 4. Numbers that are less than this number are numbers to the left. All right, so we also have to shade in our arrow. So now we want to, represents an infinite set of numbers, and so there's way too many to list them all. So we need to describe them, and our interval notation provides us a way to describe this in our solution set. Since the arrow to the left is shaded, we always go a smaller number, comma, a larger number. Although negative infinity is not a number, it's an abstract concept. There is no smallest number, but we're going to the left forever, and so that's what that is. And you'll never have a bracket around a negative infinity or a positive infinity. Values that are bigger than on the right end here, this endpoint, negative 4, we're including that, so we have a bracket here. So this is our answer. This is our solution set to this inequality. If you pick numbers that are in the shaded region, that are in this inequality, in this interval, then those real numbers will satisfy the inequality. If you pick numbers that were outside of this shaded region, then that inequality will not be satisfied. All right, so let's take a look here at number 4. Again, we start off by applying the distributive property a couple of times, and then we want to combine like terms and then step by step try to get x by itself. So I'm going to distribute the 8 to both terms in that binomial, and I get 8x minus 16 minus 5x is strictly less than, if I distribute this 2, I've got 2x minus 6. So on the left-hand side, I have some like terms. 8x take away 5x's is 3x minus 16 is less than 2x minus 6. So if I take away 2x from each side, that'll leave me with just x on the left. If I add 16 to each side, then I'll have 16 minus 6, which is 10. So I'll have my answer that x is strictly less than 10. If I sketch that on a number line, 10, say, is right here, and to the right of 10 would be 11, and the left would be 9. I leave this a hollow dot. I don't shade it in because it's a strict inequality. And numbers that are smaller than 10, that are less than 10, are numbers to the left of 10 on the real number line. So here's a graph, a picture of my solution set. If I want to write that using interval notation, the left arrow shaded, that's negative infinity, and the right endpoint 10 is excluded, so I have a parenthesis, not a bracket, and here's my solution set for this inequality for this problem. So I hope that helps, and I will talk to you later. Bye.